All right, good morning. CWZ Mike Mears, and we're here on the home stretch for Unit 8, where we're going to talk about some special transformer configurations. All right, so yesterday, day 7, we talked about single-phase transformers, that mutual inductance and magnetic coupling, that's that magic that's happening wirelessly in between two windings with some ferromagnetic material and all that magic that's happening that's causing this transformation. Well, one thing I want to make note of is that notice that when we drew up here that square there, that there was all that air in between, there was space, if you will. There was no electrical connection between those two windings in that basic single-phase transformer, which made it kind of an ideal situation if you need to create some type of electrical isolation between one side and another side, right? Between a source and a load. And you go, well, what does that mean? Well, if you remember, and I said that on this transformer trainer here, between 1 and 2 is going to have the same number of turns as between 5 and 6. And so if you put it in, you're going to get 120 on one side and 120 on the other side. I'm like, well, why would I need to do that? Well, now what you've done is you've through mutual inductance and this magnetic coupling, created a point of isolation between one side and the other, which we're not going to go into why that would be awesome in some cases. However, just know that isolation exists there. So today we're going to talk about this other transformer called an auto transformer. All right, and so auto transformer is one that doesn't have two sets of windings. All right, it just has, well, it does have two sets of windings. They're not independent windings. The secondary winding is really just a subset of that initial larger winding. So what does that mean? Well, you're still getting the same voltage in, voltage out scenarios based on those number of turns. However, you lose that magnetic coupling. You lose that isolation that's happening between two coils. The voltage regulators, or auto transformers, are commonly seen in a lot of things that just regulate voltage. All right, you can see them in rheostats that are just taking, what you're doing now is if I have this one coil here coming in, and now I'm going to put a tap right here, right? So I'm going to apply a voltage here, and then I'm going to read a voltage here and still reference a voltage off of here, and I'm going to get a different voltage that's scaled by the ratio of that turns right there. Same concept, but now I'm getting it based off referencing a different point along a common coil. So now what I don't have is I don't have this isolation here as I'm measuring off this coil, right? With this just, what was that?
There's a squeak on my chair.
I sound like someone honk a horn and come into a place. All right, you don't have this isolation piece in between there. What you have is this same coil here with taps coming off of it. All right, and you're going to be using this coil here that you may have not even seen yet or played with yet, but this coil here as your auto transformer coil to see, well, what happens if I put voltage here and then I measure voltage across here. Even though it's the same coil, I'm referencing off of something, and it's really kind of a cool concept. All right. And again, when we start talking about regulation, you can use these auto transformers because now you can make finite differences to where you're tapping off of so that you can get varied results. You know, as we're dialing something up or dialing something down, we're changing the point of reference that we're referencing on auto transformers. They're very, very common devices. So I don't need you to know how to build an auto transformer, and I don't need you to know all the super deep dark science behind the auto transformer, but you really need to know that they are common applications and kind of what makes an auto transformer different. What's some positives and some negatives of an auto transformer? Well, I mean, a positive one is it's simple, right? I mean, it's just a coil and you're tapping off multiple points. All right. Well, and you know, let me go ahead and build something real quick so you can kind of see what I'm talking about here. What are some negatives though? I mean, you know, what would be bad, I guess, about only having one coil? Well, if you did need that isolation between primary and secondary side for whatever reason, then you don't have that. All right, so there's some current issues. If you have fault current on the secondary side, that same fault current is going to be seen on the primary side and vice versa because you're not going to have that isolation in between. All right, so in this case, I'm actually going to need to steal some of my blue leads because that thing's pretty far away. That thing is in there. All right, taking two of them. Okay, Now what I'm going to do is I'm going to run 120 volts up to the primary side of blocks 1 and 2 over here. Man, that is still a little short. Let me see if that'll go over to that one. All right. So I'm going to put 120 to right there. All right. Then I'm going to take some voltage readings here, which, I mean, this is just going to be your source voltage, so I'm going to bring that up. E1. Man, I just keep coming short on these links. All right, so right now I have a circuit set up. I really only need my gauges here. We don't need to worry too much about phase angle shifts, although there is some deep dark science there with phase angle shifts. We're not going to worry about that right now. So I'm just going to bring up my gauges here, and I've got E1, E2, E3, E1, E2. Those are the only ones I really need right now. All right. So let me dial this down. Let me turn this on. Now I'm going to dial this up. All right, so I'm right about 120 volts. Okay, cool. All right, so now I want to see, well, what am I actually getting on the other side of this transformer then? Let's see. All right. I am going to set up, let's say, and I'm going to need some more blues. I'm going to go from here over to here. And then let's read from, let's say 7. I'm going to read the voltage between 7 and 3, because remember, voltage is about potential difference, so it's really about a reference point. All right? So I'm going to read between 7 and 3 on E2. Let me turn this off. I want to make it a surprise. All right. So based on what we talked about in the previous lecture on single-phase transformers, if we were to use 7 and 3 here, it's a lower number of coils, just guessing on how it looks on the panel. I mean, it looks like one's really long, so more coils. So if I do 120 to this, then I should probably have a lower voltage here, probably. So things that we know here. Things that we know are that the primary, I'm going to put in 120. And we know that V secondary should equal V primary, right? Times N2 over N1. All right, and we know that V primary is 120. Okay, so I'm just going to stop there. And now let's see what we got. Okay, so I got 120. Let me get right there at 120. Now, notice what I'm reading here, and again, I'm off just a hair. Where am I? All right, 120.1. So I'm reading 103.8 volts. 103.8 volts. So I got 120.8 and then 103.9, right? So what did I say that was? 103.9, 103.8. So V secondary is actually equal to 103.8 volts. Well, that means E1 or E pri over E sec is 120 volts over 103.8 volts. All right, which is going to give us a ratio of 120 divided by 103.8 equals 1.16. All right, 1.16 to 1. What that means is this top side, there is 1.16 more coils in here than there is here. All right. Now, let's do this same concept now, and let's meter, while we're still metering this, now let's reference, let's say 8. All right. So I'm going to bring 8 over to E2. And then I'm going to, because that's the same reference node here, I'm just going to jumper the negative side of E2 to negative E3. All right, now I'm going to come over here. I'm going to turn on E3. All right. Wow, man. Now I'm reading 180. That's pretty crazy. All right, so I'm at 119.8 and 179.9. So I'm just going to say 120, 180. So now, tapping off the same 1 setting, I'm still tapping off a 3, but now I'm referencing 8 instead of 7. All right. Now I've got V primary, 120 volts, over V secondary, 180 volts. Now, my ratio between those 2 points, all right, I believe that's 2/3 or 0.67. 120 divided by 18, 180, 0.67. All right, so 0.67, okay? So what does that mean? Well, now I got more turns on this side. So now I just went from, this is the same transformer, the same primary winding here, same secondary winding here. I'm stepping down the voltage between here, but because I'm referencing more turns on this side, I'm actually stepping up the voltage between here in comparison to the primary side. All right, so now I don't know if you remember from the Unit 7 lab. Look at that. I don't know if you remember from the Unit 7 lab or not, but I told you what the scale or what the ratio was of these two, just because I know, and you can kind of guess. You see where we're trending here. We went from 103 to 180. If we add a little bit more, we're probably going to be in the realm of something else. All right, but let's see. I'm going to check it on E4. Same thing. They're all referencing the same node, the same neutral point. So I'm just going to jumper this over to here. Go over to here, and I'm going to turn on E4 voltage, E4. Oh man, I'm at 208. All right, 208.3, 208.4. So now let's run the numbers, the same thing that we just did before. My V primary is 120. V secondary is 208. All right. So you can see the relationship between those is 1.73, although choosing 120 as the primary is going to be the inverse of that. It was the 0.707, I believe. We'll see. So 120 divided by, or the 57.4, 208 equals, 0.577. All right, so this one would be 0.577. All right, or 1 to 1.73, or 1.16 to 1. And the ratios are just all about which one you're looking to which one you're looking, right? So if you wanted to call one side the primary, one the secondary, and switch the relationship, you're just looking at the inverse. It's all the same. Okay, so that's a recap of yesterday's stuff, and you should have done that lab by now, and that was really easy to see, and you can go back and do some calculations and calculate some ratios from here. But now what I want to do, also, well, let me back up and make note, all right? So now, based on this ratio here, if I was to apply 120 to this lower set of windings here, that's why it's important not to do it, because now this winding reference is going to be way high, all right? Way higher than the 120. It's going to be that higher by the, what was our scalar here? This 1.6 right here? Like, we're gonna jump it up above what that voltage rating is. Okay, so now we're going to talk about the auto transformer, all right? Now, I showed you that just to show you the isolation. Now, let's go over to, it's 8-1, and we're going to look at the drawing that it uses for it. And we're going to go 5, 9, and 6, which you can see 5, 9, and 6 is this one right here. All right. Now, I don't know if we'll look in here on the lab and see if we're using this middle one here too, but essentially that auto transformer is just that coil with multiple taps. So, I mean, we could be using this or we could be using this. It kind of doesn't matter, but let me take this down. All right. Now, I'm going to keep my circuit set up the same. All right. I am going to meter those same values in between every one and kind of show you where we're at. The only difference is I'm going to dial my voltage down. Now, remember, one of these labs is also going to have you do some strange stuff on this auto transformer. Pay attention to what voltages you're actually putting in, because I believe, let's look over here on step 13. All right, it's going to tell you that you're going to be tapping into 9 and 6 on this one right here. And you're going to read the chart, and it's going to say, using 120, this is your setting. And so you're going to immediately think I apply 120. Well, based on what I just told you, if I applied 120 to right here, and I tapped off of right here, you're going to put 208, or actually that one right there would be even more, that'd be by a factor of 2. You're going to put 240 to right here, which is going to start cooking my transformers. So don't do that. Pay attention. You're going to set your voltage at 50. So I'm going to dial this down. All right. Now, I'm going to bring my source voltage up here. All right. And I'm just going to go between here and here. And what I'm doing now is I'm applying whatever voltage I have at my source across this coil. However, I'm still metering these various points of this coil right here. Okay? So, again, voltage down, turned up. Now I'm going to start dialing up. And that's pretty cray-cray, right? So I'm only giving it 20 volts now, 21 volts. E1 is my source voltage. All right? I'm giving it that. And, I mean, what's happening over here between E3 and E4, where I'm measuring between here and there, we're seeing voltage increases, right? But it's just that one coil, all right? Now, so as I go up, and again, that's why this is important, because now you're seeing, all right, I don't want to put my coil to more voltage to my coil than what it's rated for. But what you can see now is that I'm getting these voltage spikes, all right? So now E1, I'm measuring just my source. So I'm providing 33 volts. Now E2, what are we measuring? E2 is measuring the same thing as E1, because now I'm just putting my across this coil right here. That's why those numbers are the same. But now E3 is measuring between here and here, and E4 is measuring between here and here. And so now we're seeing that depending on these points of reference, we are getting varying degrees of voltage off of one coil. One coil, and that's it. That's the concept of the auto transformer. It's really, really cool. All right, so I'm going to demonstrate one more thing here. Let me turn this off, and I'm going to, again, just for consistency's sake, I want you to understand why I don't want you, why on earth I don't want you to hook up 120 to any short windings on here. Now what I'm doing is I'm going to meter voltage. What do we got here? All right, so I'm going to meet E2 and E3 is going to be the voltages between here and here and here and here. All right, I'm going to provide source voltage between, let me dial it down, between here. Actually, I'll do it just like the lab shows you, is going between 6 and 9. So I'm going to go between here and here, all right? And I'm going to meter right now. Let me do my source metering, which is between there and there. Then E1 or E2 is between there and there, but I actually want to read between there and there. And then E3, I want to read between there and there. Let me change all around my neutral references here. Bear with me. Got to reset my direction using the 6 instead of the 5 on here. All right, so I'm bringing that to that. I'm bringing my source voltage up to 9. Okay, so now I'm going to measure my source voltage between here and here, which is up to, let me flip-flop these, E1, E2, or E1, back to there, yep. All right, now E2, I want to measure between this reference here, which is this, all right, which I'm going to jumper from over here. All right, so I'm going to measure now from here to here, yep, up to that, and then E3, I want to measure my full-blown stuff, so I'm going to go E3 between my neutral and here, and this is E2. I'm just going to go from here over here, take this wire out, and voila. All right, so now what I'm doing is I'm applying 120 volts. Well, no, I'm not going to apply 120 volts to this right here. I'm going to apply a source voltage to this right here and scale it, and I'm going to show you the different readings between now source voltage and my full range voltage here. Same thing that we did a minute ago. All right, so notice that E1 and E2, they're reading the same thing on how I go, well, pretty close to the same thing on how I got it set up. But E3 is now reading that full range, and you can see it's by a scale of 2, right? I'm scaling up the supply voltage by 2. So right now, I'm going to dial this up to 60 on my source, like the lab says, 60, not 120. And then I should read a voltage of 120 across the outer leads. I mean, assuming science is correct. There we are. Let me back up 1 volt. All right, so you can see now, I'm applying 120 or 60 volts to this right here, and I am actually measuring 120 volts when I go to the further coil. All right, and again, it's because of this cool thing called inductance and how these transformers work and how the auto transformer works. Now, if you haven't picked up by now, that seems like a much simpler function now, because all I did was provide something to this one coiled up thing and then just tapped off of it to read a better voltage. That seems pretty simple. I mean, and it is. Although you lose some of the things such as that electrical isolation, and fault currents can cause some problems. But just know and understand that is considered an auto transformer. All right, now we're going to talk about transformers in parallel. All right, what happens if I take this one conductor here and I look at it and I say, how many amps can I put through this inductor? I mean, this conductor. How many can I do? Well, it's all going to be a function of the material science of what type of conductor it is, what the rho value is, which is more science stuff, whether it's copper or aluminum, how much resistivity the copper or aluminum has, what's the length of it, how much current can I put through this? Well, I'm going to get a value based on all that sciencey stuff, right? Get a value, or I could read some stuff out of like the charts in the NEC. It's like the tables 310.15 or 1718, something like that. But now I know, though, if I take this same conductor, I take one of equal value, I hook these two ends now together like so, and now I have the same length of conductor, same conductor, same size, but I put two of them together. What did I do? Well, I caused more material, right? Well, more material, it goes back to that property science stuff, right? And if these electrons are wanting to go on the surface area of the conductor and they're wanting to float along in that space, and I'm giving it more surface area, more conductor, more material, then what am I doing? Well, I'm doubling the ampacity of this circuit, or of this conductor. I'm by putting something in parallel with it, I'm providing more capability to the circuit here. All right, so how does that apply to transformers? Well, the same can be said about a transformer. Now, and it kind of all goes back to that ampacity, because what is one of the principal ways to calculate power is P equals IE, and in parallel, right, depending on the type of, whether it's single phase or three phase, we're going to have similar voltages, right? But if we add more conductive material in there, more transformers, in parallel, we're adding more material in there, and what that's doing is it's increasing the power capability of those transformers, the output side. So now, for instance, if I have one transformer that's, let's say 100, rated at 100 kVA, and I put it in parallel with another one that's 100 kVA and another one that's 100 kVA, so I got 3 transformers, all in parallel, all single-phase transformers, all in parallel, 100 kVA. What do I get capacity-wise? Well, I get 300 kVA worth of power output, all right? So that's one of those principal things about transformers in parallel is that you're increasing your power capability, all right? Now the lab, this is going to be 8-2, and 8-2 is going to walk you through some calculations of doing one, applying some voltage. You're going to put one in parallel, apply some voltage, you're going to read some current, and then you're going to do some calculations. But I mean, the real big takeaway on this is what happens when you put these things in parallel is that you're going to increase some capability and increase the power production, or not power production, the power carrying capability, current carrying capability of your system. And it all goes back to this concept here, is that you are allowing more amps to flow through your circuit using a similar voltage. Think about your house in parallel circuits, and we have parallel branch circuits all along this building here. And every single one of them is another grouping of wire that's running in parallel with another branch circuit. And every time I've done that, I've increased the current carrying capability of my system as a whole. However, I mean, our box, we still need to make sure that in our panel, that cable that they're all coming to can meet the, if we keep adding, right? These effects have second, third order effects that you got to go backwards with. But by increasing the conductor, we're increasing the current carrying capabilities of our system. And so by putting these in parallel, we are increasing the capability of our system, all right? And so, we don't have to spend a whole lot of time on that because, I mean, really, I don't know, it's kind of some simple stuff. So let me look here to make sure that we're not doing it. And again, transformers in parallel lab, there's going to be moments you're going to be using 60 volts for the source voltage. Pay attention to what you are doing in the source voltage. Do not put 120 when it says put 60 because you will potentially let the smoke out of my transformers and you're not going to be able to catch it all in time to put it back in. All right, so then the last portion of day 8 is going to be talking about distribution transformers. And a distribution transformer is really one of the most common ones that you're probably familiar with, or I've said there's some other stuff that are pretty common that you should be familiar with, but I don't know, I guess it depends on what type of neighborhood and how new the neighborhood is and where you live. But when we refer to these distribution transformers, we're talking about those little buckets that you see up on the poles. And I drew one in another lecture, kind of give you an idea. We've got this bucket that's up on this pole, right? It's mounted here, power pole here, right? Here, and this is the one where I said we had H1 and H2. And then we had these conductors here. And you see these little squiggly lines that tap up into a little bolted connection here. Squiggly line, tap into a bolted connection here. And then we see these on the front, right? And then we see those wires going in, and again, back to us in our happy little house with power. Okay, this right here is what we're referring to as that distribution transformer. And there's some unique things about these distribution transformers that a lot of people don't know, or a lot of people aren't familiar with. Well, let me back up, and this is the visual representation if you're looking at it. But when you actually see it in an electrical schematic, and when you see it over there, I want you to make the connection between this right here this and this. Now look up here what you're physically seeing. You're seeing these 2 points up here that are connected to the high voltage side, and then you're seeing these 3 points over here that are connected to the low voltage side. It's primary side, secondary side. When we look at it schematically here, this is the equivalent. And it's important to know so you understand what's going on here. If I'm reading a voltage across here, a single phase voltage, mind you, if this is my neutral point, which I drew over here, N, A, B, and C, all right, and I'm reading neutral to A here, based on that, I'm getting a single phase voltage across here. But just like I saw on that auto transformer, I'm able to tap different voltages off of the same coil. So what does that mean? Well, that means between, so let's say, here and here, I'm reading 120 volts, but from here to here, I'm reading 240 volts. So what does that mean? Well, that means it's exactly like this little split right in the middle point between 5 and 6 over there. And that's what's going on in your house. And that's how you're actually able to take a single phase power in, and you're able to get two different voltages inside of your household. And you might not even have known that, but the compressor in your alternator, in your air conditioner is more than likely running off of that 220 or 230, 240. Your hot water heater, if it's electric, it's running off the higher voltage. Your stove should be running off that higher voltage. And so, unless you live in a really old house, you have two voltages, and this is how you're getting two voltages, even though you don't have multi-phase power in your house. And we just demonstrated that on an auto transformer, where you saw me take 120 volts and put it in this coil right here, and somehow I magically got twice the voltage out. And in the same moment, mind you, it wasn't two different moments. In the same moment, I'm getting 120 from here and 240 from here, or how I did it, 60 and 120. But it's happening at the same time on the same phase because of where you're tapping off of that inductor. It's important to note. A lot of people just assume, I have two-phase power. You don't have two-phase power. It's just you're tapping off a different point on that inductor. All right, there's different phase angle relationships that are going on that's giving different references, and it kind of goes back into some deep, dark science. You can just trust me. All right. Also on distribution transformers, you're going to see some common ones too that here I drew it like this, but you'll see some, especially on the Leclerc electric tour, that you're only going to see one of those H paddles. Well, the reason for that is that H2 is bonded to the case, which is then bonded to the ground that is going down to the pole, which is going to a pole ground. So really, this is coming off down through the pole. And so, I mean, this right here is a good indicator to you too, just by seeing that you've got a phase to ground connection there, voltage reference that you're using to put power to that transformer, but you're still getting multiple voltages out of the secondary side of that. It's not because it's a two-phase system, all right? It's because you're just referencing different points on the coil of that transformer. And that's a really good takeaway to know and understand when you're doing this lab. Now, the distribution lab, the trainer's going to take you through doing the same connections between, let's say, 3, 4, and then 5 to 2. 3, 4, where are we at here? The 3, 4, oh, this one right here, and then we're going to take 5 to 6 here, and then 1 to 2. So you're actually going to connect all of these together. You're going to actually make this is going to be a little counterintuitive, because before you were looking, this is one coil, and one coil, like all in one. Now, in this lab 8-3, you're actually going to take this coil and put it in series with this coil, and that's going to become one winding. Then this coil is going to be the other winding. So it's going to be interesting. Just pay attention to the numbering system that you're using, and know this is the one that you're using. Okay. Now, another correlation I want to make is that on this three-phase transformer trainer that you're going to see right underneath it that we're going to talk about tomorrow, you're seeing the same schematic that I drew up here. However, it's inverted by 90 degrees. All right. But this is the same thing here. Now, again, if you were very, very high speed and you did the math, you could do that same lab using this. However, your results are going to come out slightly different because it's a little bit different proportionally here. All right. So I encourage you to just use this transformer trainer right here, especially if I catch you using this one and smelling my smoke being let out, because that's going to really make me mad. All right. So just know the numbering conventions of your nodes and your points and your connections on these Unit 7 and Unit 8 labs. It's very important to pay attention to it and pay attention to what the source voltage is. So, with that being said, the big takeaway from 8-3 with this distribution piece is it's just going to show you a lot of the same things that I just showed you. You're going to calculate in some circles on how that works, but really you're just showing how you're putting in one voltage and you're getting out a couple different voltages. So you can understand that relationship in these external distribution bucket type can transformers that are going to your houses. So don't get too wrapped around the axle with it, but understand the practicality in all this, so you can really kind of just put together what's going out there on the pole. All right, so with that being said, I want you to knock out labs 8-1, 8-2, 8-3, do the quizzes, do the unit quiz, and then finally, one last time, please, for the love of sweet baby Jesus, do not put 120 volts between any two really closely connected leads on my transformers. Please, 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 and if you smell it cooking, turn the power off. Thank you.